Alright, now we move on to resistance. So we just now we're done with potential difference. Now let's move on to the last major part on electricity. We talk about the resistance. So resistance is the opposition to the flow of electric charges. Okay, the greater the resistance circuit, the lower the current, and also vice versa. Okay, which means that if the lower the resistance in the circuit, the higher the current. There's actually a formula here that will help, so please take this down. V equals to IR. For a constant voltage, okay, for a constant voltage, when I increases, R must decrease. So you can see here, if the voltage is constant, which most of the time depends on the battery, when the resistance drops, the current will increase. And obviously, when the resistance increase, the current will drop. So this is a relationship that you should remember. V stands for your voltage, I stands for your current, okay, current, and R stands for your resistance. You can also think of it this way. When the resistance is high, would there be a lot of charges flowing? Just think of it like a traffic jam. When there's in a tunnel, okay, in a tunnel, you have a lot of vehicles there. The traffic is very heavy. There's high resistance. So would you send more vehicles through the tunnel? No, right? So take note, resistance. The higher the resistance, the lower the current. Okay. Now the units for resistance is ohm. The sign here is the omega sign. So example, resistance of light bulb 1.5 ohm, resistance of a hairdryer 8 ohm. Okay. Now a resistor is actually also an electrical component. It's used to resist the flow. So for example, I want to control the amount of current flowing, I will use more resistors or increase the resistance of a circuit. So how does it function? Okay, resistor is actually made of material that has poorer electrical conductivity. Okay, so that's why it can oppose the flow of electricity, of the electric charges. So take note here, we talk about resistance being the opposition of flow. It's made out of a poorer electrical conductor to oppose the flow. In real life, we tend to look at, there's these two kinds of resistors. One, we call it a fixed resistor, where the resistance is fixed. That means if it's a 5 ohm resistor, it will forever be fixed at 5 ohm. Okay, it doesn't change. The other one is we have the variable resistor, which means that the resistance can be varied. So how do they look like? Now, these are the fixed resistors that you'll see. In the circuit boards of many appliances that we use, you tend to see these resistors here. Okay, this one is generally you'll see them in the lab. Okay, this also is a glass tube resistor. Same thing here, this is the same as this. Okay, so these are the examples of your fixed resistors. For variable resistors, you have this one over here. This is called the rheostat. You can actually control the amount of current that's flowing. You just this black knob over here, you can actually push it towards the right or push it towards the left. Okay, by pushing it left and right, you're actually able to control the resistance. And all these things over here, okay, these are actually wires, okay, coiled up. So in actual fact, this rheostat uses wires. Okay, sorry, it looks like wine to me. Okay, it actually uses wires. Okay, or I should say the length of the wires. It looks at the wire's length to control resistance. Okay, the longer the wire, the longer the wire that I have, the greater the resistance. Okay, so this is your variable resistors, where the resistance can be varied by adjusting some knobs. So this marks the end for your resistance too.